Hello guys. So today I will be briefing you about a programming language that we have built for the subject SER 502 Programming Paradigms under Professor Ajay Bansal. So we basically have built a programming language named BolBachchan. I have built this language with my team containing Vidhisha, Charu, Aditya, and our group number is 32. So the contents of this presentation would be uh, uh, we will firstly look into the introduction of a language, then we will go through all the features that we have included in that language. I will briefly show you the flowchart and all the processes that are included in the our language, and then my teammates will brief you on grammar, tokenizer, parser, interpreter, and main.py. Then we will also educate you about the instructions to execute and some snippets about the sample code. So moving on, the introduction to our language. So BolBachchan is a very creative and humorous programming language. Basically, we have blend the Hindi and English keywords together to make it a funny and interactive language where some keywords like bol bhai will be representing print and so on. So in this language, we have designed our own custom lexer and parser, which is backed by Python. We are basically using PLY, YACC for this. And moving on, I will now tell you about the features of BolBachchan. So we have included three primitive data types, int, bool, and string. And we have added the arithmetic operators and relational operators such as addition. Addition is represented as jodo, hatao is represented as negative subtraction, and so on. We have also included loops, then conditions, operators, print statements, assignments, logical operators, and we have also added a custom function feature, which is a brown point. Moving on, now I will show you the flow of our language. So basically, main.py, which will be the main file, first file, will be taking our sample code, which will be having an extension of .pb representing BolBachchan. Then the data file will be transferred to the lexer.py, which will then convert the whole file into small tokens. Then these tokens are passed on to parser.py, which will then convert these tokens into a parse tree. Then this parse tree is passed on to the interpreter.py, which will then do the operations on the parse tree and give the results into an output section, which will basically be our CLI terminal. So this will be it for my side. Now I will be uh, now my teammate will be explaining more on the grammar. Vidisha, can you take on?
Thank you. So for our language, we have used E, B, and F as our grammar. So why we have used this is because firstly, it is a standard format for specifying programming languages. Secondly, it is easy to read and perfect for documentation. Thirdly, it is language agnostic. That means it is not tied up to any specific language. And lastly, it is widely supported by parser generators. Now we'll dive more in detail. So our grammar, it supports a variety of constructs as required by the language constructs. So firstly, we have primitive types. That is, it supports Boolean values, that is true and false, with logical operators, that is and, or, and not. Then it also has numeric types, that is data types. It has int, it has bool, and it has string, which also has arithmetic operators. That is, jodo means addition, gatao means subtraction, gunao means multiplication, and bhag means division. Then it has relation operations, that is bada hai means greater than, chota hai it's less than, and barabar hai it's equals. And we are also giving string literals that are that are also supported with assignment capabilities. So for assignment, we have a keyword named rakho. For example, we have rakho x is equal to 10. That means we have assigned the value to the x. And we are also given conditional statements, that is the traditional if then statement, that is agar and to. And we have ternary operator as well. For loops, we have while loop, that is jab tak, and we have also given for loop, that is bar bar, and then the condition. And finally, we have print statement, that is bol by, which is our print command. So it supports this print command. It supports all the data types, numbers, booleans, and strings. So in short, these grammar rules ensure that the language is expressive enough to handle any logical computation and control flow. Now we'll look for the lexer, that is tokenizer part. So lexer, as we know, lexer is a component that treats a source code and then splits it into tokens, which are the smallest meaningful units like keywords, operators, and identifiers. So over here, we are first defining a token list that it has ID. ID means identifier. We have numbers. We have plus, print, etc. So what these tokens are used for, it's basically used later on for parsing. Then next we are having the reserved keywords. That is, it helps in mapping keywords. For example, rakho, bol, by, agar, to token types, that is assign, print, or etc. Then we have token rules. So over here we have different types of token rules. For example, we are defining patterns for symbols and operators. For example, equals to increment operator or ternary operators. Then we have literal matchers. That is, we are matching for strings. That is in double quotes if we have any letters or anything. Then we are looking into integers, and we are also looking for identifiers for literal matches. Then we have next on, we have a reserved keyword check for the identifier. So over here, basically this function, what it does is it matches the identifier like for a reserved keyword, and it is, if it is found, then we are using it as a keyword, and if it is not found, then we are throwing a error over there. Then next we are looking at we are ignoring any characters such as white spaces. We have tabs. We are ignoring all those kind of characters. Then we are looking at new line handling, and we are also looking at error handling. And finally, we have lexer initialization. That is, it builds the lexer using all the definition that are given above. So in short, what this lexer can do is, first it recognizes any custom Hindi-like syntax, that is rakho, bol, by, agar. It also handles operators such as jodo, ghatao, that is addition or subtraction. It also detects invalid use of reserved words. And lastly, it tokenizes the source code into logical units for parsing. Now I'll give it to my friend Aditya.
Thank you, Vidhisha. Yeah, my name is Aditya, and now let's move on to one of our core component, that is parser. Our parser was built using PLY, that is Python Lex-Yacc, which allows us to write grammar rules in Python in a clean and structured way. We choose EBNF form, that is extended Backus NOR form, for defining our grammar, since it's readable and widely used and supported by other parser generators. So here's how it works. So once the tokenizer identifies valid tokens from the source code, these tokens are passed to the parsers. And using the grammar rules we defined, it constructs a parse tree, which captures the hierarchical structure of the program. These trees form the foundation of understanding how each part of the code fits together. Okay, we can go to next slide. Yeah. So our parse tree supports different kind of statements, such as variables, variable declaration using type ID. Then there are assignments using recurve, and then there will be print statements with bolbhai. Then there will be conditional with agar to and nahi to, and there will be loops like jab tak for while loop and bar bar for for loop. So next slide, please. Yeah. So let's talk about the next types. That is the parser also supports different types of sentence that will be again it is mentioned on the slide, that is print and conditional and all of that. So next slide. So the parser handles various types of expression that are arithmetic expressions, logical expressions, ternary expressions, and also unitary operators that are incremental and decremental operators. As you can see on the screen, let's start with the relational operation. The relational operations consist of, let's say, बड़ा है, छोटा है, bar and bar bar. बराबर है, that is equal to. And then ternary will be basically true and false. And then logical will be and or. So moving to the next slide. So this okay, so this will be the for loops and if else loops that we support using our language. Then next slide. Uh, yeah, so moving towards the syntax level error handling, our language also supports syntax level error handling. So basically, it will pinpoint the location of exactly where the syntax error is happening on the program, and then there will be function declarations. Now, one of the powerful parts of our grammar is to support for custom functions, which the function keyword use with the use of function keyword. Users can define functions with parameters and return type values, that is using wapis, that is a return type value. So next slide. So yeah, that is yeah. Finally, we assign the generated parse tree to the global variable that is parse tree, so that it can be passed to the interpreter. Once the parser builds the structure, the interpreter takes over. It reads the parse tree and actually performs the action, just like how Python executes its own bytecode. Uh, yeah, you can move on. Yeah, so this will help you generate the parse tree, and then let's talk about the interpreter and walk through the execution. Let Here's what the interpreter does. If it sees a print or expression node, it evaluates the expression and prints the results. Then for assign and var expressions, it stores the evaluated values in the symbol table. And then for loops and conditional, it uses the backend Python technology to like implement the loops and stuff. And then there will be a function call. So during function call, it manages the scopes, the past arguments, and handles the return value. We build it using a recursive descent model where each node type is handled by a specific function. So yeah. So next slide. Our interpreter handles scoping using dictionaries. Each function calls get a new scope. Variable values are stored and fetched as needed. Return values are passed back. As you can see on the screen, this the next slide. Yeah, this is the binary operator. Next slide. Yeah. So this brings structure and control and execution like proper scripting language. So let's see the flow of the word. To tie it all together, the main.py triggers the execution. Lexer.py does the tokenization. Parser.py builds the parse tree, and interpreter.py runs the logic based on that tree. This flows ensure that language behaves like a real programming language, but with a fun Bollywood twist. Moving to the next contestant, that is Charu.
Okay, thank you, Aditya. So right now we have gone through all of the main part of our language. Let me go through the starting of the language, like where the execution starts and then how our samples are running. So the first thing is, let me walk you through the main file. So the main file is basically where the code starts the execution, it's the starting point. And this is the main block. This is the primary block. And in this block, we first see that the sample files that we are giving is in .bb format. And then we are going to say open the file. Whatever file is in the terminal, given in the terminal, just open it. And then we ask it to read whatever the sample is. And then, as my friend stated before, we will go through the steps of the languages, flow of the languages, and we'll have the result. And but while we are printing the result, to make it better, we call a function called as print as a parse tree. And in this, we are going to print the output in the tokens are printed in a parse tree, so it is easier for visualization. It's easy for debugging, and also we also print the actual final output of the language, also output of the code basically. So let me run you through the first sample. In the first sample, we are telling you that we are showing that the language supports assignment declaration, assignment and the declaration of variables and the integer. And then we also support the print statements, so which is bolbhai. So let me run it. Yeah, so this is the first output. We have executed 10 plus 20, and then we have also executed BolBachchan, hello BolBachchan. And Jodo is basically the addition operator that we told you before. Next, we'll move on to the next sample, sample 2. In the sample 2, we are showing you the logical operators that can be used and the ternary operation that can be used. And again, the assignment that is already present and the print statement that is already present. And we also have the increment operations. So let me run this and show you the output. Yeah, so we have the parse tree, and then we have the execution to each of it. We are asking if 5 is greater than 10, and it says false. And then we are saying check the ternary if x is less than y, which is 5 is lesser than 10, then it's printing yes. And then we have the last increment, the flag and the increment. Let me move on to the next sample. In sample 3, we have already showed you the assignment, the declaration, the ternary, the logical operation. Here we are just adding in the conditional statements and the loops that we have implemented in the program. So the conditional statements are here. So agar to is like if else, if a, which is a was already set as 15 and b is 5. So if a 15 is equal to 15, then uh, we need to say that a is 15, and then otherwise we'll say that a is not 15. So that, let me run it. And then we also have the if else, sorry, we have the loops. So if loop, and we have the next loop. So let me run the code so that you can see the, oh sorry. Yeah. Yeah, so we are printing in the counters, we are printing in the if else statements and the conditional statements. Let me move on to the next sample. In this sample, we are trying to demonstrate an additional factor that we are implementing small codes or programs that is practical. So for example, let me see. So this is the sum. Sorry, this first one, this is the max. So it says ternary operation like, okay, if x is max then y, or if it is max, then print x or y. Then we are going to print in that which is a maximum value. And then we have this particular line of code sums the value from 1 to 5. And then we are showing you a factorial implementation of our program. And then we are also showing you if else with a flag. Let me run the code. Yeah. So you have the maximum value, you have the sum from 1 to 5, and we have the factorial and the flag, which was already false. So it's printing that flag is false. The last implementation, the fifth sample, shows you the function implementation in our code. So we have implemented two basic functions. One is add function and one is greet. Add just jodo, which is a keyword which adds a and b, and then we have a greet which adds which prints takes in hello, and then it takes in the name that we give, and then it prints the hello plus concatenated name. Let me run that. Yeah, so hello BolBachchan is printed. So greeting is done. So yes, so this, and also we also have the error handling which was already stated. So if we use a reserve keyword for the variables, then our program states that it's a syntax error at a particular point, and if we miss a colon, then it again states the syntax error and some other features like that. So yes, this is our function. I'll go run you through. This is our execution output that I already showed you. So yes, this is our BolBachchan, and thank you.